Hello, EP Calculus folks. Here we are again, and we're working on talking about chain rule, and some of these problems we'll get into the tricky uh, sides of the chain rule. So when we look at this first problem, I want you to just take a look at it. I want you to try to figure out what the derivative would be. I'm going to write pause on the video. You just give it a quick shot at what you think it is, and then when I cross off pause, then I'll begin. Okay, we're ready to begin. So this is a function within a function. So I like to break it down for my students as y is a function of u to make it real easy for the chain rule. We say u squared. And then u as a function of x is x cubed plus 1. I take the derivative of each and we get 2u for dy du, and we get du dx is 3x squared. And by using the chain rule, we just multiply these two together because we want to find the derivative of dy dx. That's our goal, which will be equal to dy du times du dx. When we do that, we multiply dy du, we have 2u times 3x squared from du dx. Now, the only problem is this is a function, we're trying to write the derivative in terms of x. So I need to replace u with its original function. This is a really good concept to review, especially right now before the AP exam, because we're going to be doing work with substitution method, which also requires making a U-substitution. So practicing chain rule this way, refreshing your memory with how we did substitution, or well, chain rule with substitution in the beginning of the year will also reinforce how we do substitution with integrals. Final answer, choice E when we multiply the 3x squared by 2 times x cubed plus 1. Next one, this is a triple layered substitution. The outer function, the middle function, the inner function. So I'd like you to give this one a shot on your own. I'm going to write pause. And when I cross it off, you can pause the video right now and fast forward to where I cross it off and then begin the video. Okay, so f as a function of u is going to be sine of u. U as a function, I need another inner function, so I'm going to use w, is equal to e to the w. And w as a function of x is equal to negative x. Some people do like to use this thing called the onion rule, where they work from the outside to the inside, but sometimes they forget a layer. So this is why writing out the layers is really good. So what we do is we're going to take the derivative of f of u. F prime of u is just going to be simple cosine of u. U prime at w is equal to e to the w. And w prime of x is equal to negative 1. You multiply these three together, and let me just demonstrate the chain rule. We have df du multiplied by du dw multiplied by dw dx, and as you can see, this will result in us finding df dx, which you can see here the way that the derivatives are all chained together, and that's why they call this the chain rule. My answer is going to be cosine of u times e to the w times negative 1. So what we're going to do is we have to back substitute all the, for instance, I have to back substitute in, I have to write cosine of e to the w. I have e to the w still, I have negative 1, so now I have to get rid of the w's. So in the w's were just negative x, so the final answer will be cosine of e to the negative x, e to the negative x times negative 1. And now the chore is to find that solution. I think that solution is this one, negative e to the negative x cosine e to the negative x. Yeah, that would be it, choice E. Okay, also make sure you give yourself plenty of time to make sure you get the right choice, because that sometimes is the toughest part. You find the answer, and then you have trouble lining it up with what their choices are, because they might have an altered form. I want you to try this one. I'm going to pause the video. And when I unpause it, I want you to watch what I do if you don't get the correct answer. Okay, we're back, and this again needs a U substitution. So I'm going to say f of u equals ln of u. I have an inner function, so I'm going to say u of w equals, well, actually, I'm going to just go with u of x, and that's going to be x plus 4 plus e to the negative 3x. I'm going to assume that we know what to do when we take the derivative of e to the negative 3x because it's a mini chain rule there. But let's just take the different parts. F prime of u is the natural log, is 1 over u. And u prime of x is equal to 1 plus negative 3e to the negative 3x. And that negative 3 is from taking the derivative of this part right here. So that's like a little mini chain rule going on. So they've got a chain rule within a chain rule. But now we put it all back together. I have 1 over u times 1 plus negative 3e to negative 3x. Now remember, when you multiply fractions, this part is in the numerator, so that comes up on top. So I'm just going to rewrite that up in the numerator. I have 1 minus 3e to the negative 3x, and then for the u spot, I'm going to change that to x plus 4 plus e to the negative 3x. Now this would be my derivative, f prime of x. They want to know f prime at 0, which is really nice because when you plug 0 in, most things change to either 0 or 1 depending on the function. So here on the numerator I have 1 minus 3, and then e to the 0 is going to be just a 1. On the bottom I'm going to have 1 plus 4, I'm sorry, no I'm not. I'm going to have 0 plus 4 plus e to the 0, which is 1. So my final answer is going to be negative 2 over 5, and that would be choice A. Another chain rule problem. This is a chain rule problem where we're working with an integral function. So give this one a shot. I'm going to write pause. Give this one a shot. Remember, these questions should take 1 to 2 minutes. They shouldn't take any longer than that. But I want you to give it a shot and then come check out what the video says. Okay, so we're back. Hopefully you gave it a shot. And I'm going to try f of u. I'm going to first do that as just the integral function. It's from 1 to u, and then the square root of t squared plus 3 dt. Remember, it's an integral function, so this is like a dummy variable. So that inner function business doesn't really matter because the function is an integral function. The first derivative taken will just get rid of the integral symbol, and I want to write u as a function of x is equal to x squared. So we definitely have a chain rule going on here. The derivative at u is going to be just what was on the inside of the integral. So it's going to be u squared plus 3. And the u prime is going to be 2x. So now we put it all back together. We multiply these two parts just like we did before. I have 2x out in front, the square root of u squared, which I want to write u squared, but I've got to change it back to an x function. So it's x squared squared, which just becomes x to the 4th plus 3. So now I've got to plug in my value at 2 because they said find f prime at 2. So that's going to be 2 times 2. And then in the radical, it's going to be 16 plus 3, which will give me 4 root 19, which is choice A. Next one is, so this is a problem that was from a review book. This problem here, I think, was from the actual AP test. You can see that there's a little bit of, I don't know, I'd say that this looks very familiar to what's been given before. It just shows you that a lot of the problems are very, very similar. They're not going to be exactly the same, but by going through this type of tricky review, it gets you your calc skills aware of what you might see on the actual test. So try this one out. I'm going to pause the video, and then when I erase pause, we'll be ready to go. Okay, so here we go. We say find the derivative at 2 again. So we have f of u is equal to the integral of 4 to u root t squared minus t dt. And then u of x is 2x, and a lot of people can do this without this notation at this point. So f prime at u is just going to be root, because of the integral, the derivative of that function undoes the integral symbol, and then we're just left with what the integrand was. So that's going to be, u squared minus u. And now at my u prime of x is just 2. So now when I multiply these together, my derivative is 2 root u squared minus u. Now, I have to go back to x's because it said find f prime at x equals 2. So I've got to go 2 root, this is going to be 4x squared, because when you square that, you get 4x squared minus 2x. I'm going to plug in 2, so I have 2 root, this will be 4 times 2 squared is 4 minus 4, and that's going to be 2 root 12. So my final answer there will be choice E. Hopefully this helps. How about we take one more look at number 4. You give that one a shot, and it's again a triple integral. The outer function here is x cubed, because that's the outermost. Give it a shot. I'll pause the video and then we'll look at the answer. Okay, so we're back, and I know there have been a lot of problems in doing this video, but I think this is good practice. Hopefully you've had a shot to try them all. F of u equals u cubed, because that's the outermost function. U of w equals cosine of w, and w of x equals 4x, 3 layers deep. So we now have f prime at u is 3u squared. U prime of w is negative sine of w, and w prime of x is equal to 4. Multiply them together, 4 times negative sine of w times 3u squared. Back substitute, so first I'll put the u's in, which will be negative sine w, 3, the u squared was cosine of w, so that's cosine squared of w, and then now I'll substitute back in the w's, and that w was 4x, so I've got negative sine of 4x, and I've got 3 cosine squared of 4x, and if you look for that answer, you're going to be looking for negative 12, so it's either that one, let's see if that one works, negative 12, cosine squared of 4x, sine of 4x, and that is the answer, choice B. If you analyze the other answers, you could see that those are good possibilities, but where they may have forgotten a step of the chain rule. Hopefully this video has helped, and I look forward to hearing your comments either in class or if you just write them back on the YouTube channel.